What's up everyone? Here are the solutions for worksheet 11, and the first problem is a Newton's method problem. We are asked to find, using x1 equals 2, we are asked to find a second order approximation to the given function here, right? So just to remind you, for Newton's method, x sub n plus 1 should be the previous approximation, the previous term in the sequence, minus f of x sub n divided by f prime of x sub n. So we need to compute the derivative of this function. Let's see what that's going to be. F prime of x is going to be 2x. That has derivative 0, and derivative of sine is going to be cosine, so plus pi cosine of pi over 2x. And where this pi comes from is the derivative of the inside, which is pi over 2, but when I multiply by the 2 in front of the sign, I end up with just pi. So those are the pieces that we need, and now we are ready to calculate x sub 2. Let's see, x sub 2, that's going to be x sub 1, so 2 minus f of x sub 1, so that's 4 minus 1. Okay, sine of pi over 2 times x, that's going to be just sine of pi, which is 0, so that drops. Over now, when I apply, when I plug in 2 into the derivative, I get a 4 here. And cosine of pi is negative 1, so I just subtract this pi here. Okay, and so let's see what that ends up being. That's just 2 minus 4 minus 1 is 3 on top over 4 minus pi, and I'll leave it like that because it's not going to be, a very nice looking answer. Okay, for the second problem, the same thing. We have a equation this time, and we're asked to solve the equation using Newton's method, right? But we're only asked to find x2. Now, the function corresponding to the equation is the function that I obtained by moving everything to one side. So f of x is going to be 2 plus 4 sine of x minus cosine x. And in essence, I'm trying to find zeros for this function, right? That's the equivalent to saying solve the equation that is given here. So again, we need to calculate f prime, and f prime of x is going to be 4 cosine of x plus sine of x, because the derivative of cosine here is negative sine, but with this negative sign, that makes it a positive sine of x. Okay, and now if I want to find x sub 2, whoops, that's going to be just x sub 1, so pi over 2, minus, on top here I'm going to have f of pi over 2. So when I plug in pi over 2, I have 2 sine of pi over 2, that's 1, so plus 4. Cosine of pi over 2 is 0. And I divide this by plugging in pi over 2 into my derivative. So 4 times 0, because cosine of pi over 2 is 0, sine of pi over 2 is 1, so plus 1. So this is now just pi over 2 minus 6. That would be the second order approximation for the root of my equation. And I'll leave it like that. There's no, there's no nice answer for this, especially since we have an irrational number pi. Let's move on to the next page. And for the third problem, problem 3, we're asked, okay, suppose that a function has a root a, right, has a 0 at a. What happens if we try to apply Newton's method with a as the initial value? So just to remind you, we had for Newton's method x sub n plus 1 equals x sub n minus f of x sub n divided by f prime of x sub n. So if I plug in a for x sub n, notice that the numerator over here is going to give me 0, and as long as my derivative is not 0, right, so as long as f prime is not 0, that tells me that x sub n is 0 for all, not 0, f sub n is a for all n, right? In other words, it's going to be the constant sequence a. For problem 4, we are asked to find some slant asymptotes, and for the first one, because I'm only dividing by x to the first power here, right? I don't have any plus terms or anything like that. It's very easy to find the asymptote. All I do is I split the fraction as x squared over x plus 4 over x, and this is the same as x plus 4 over x. So this linear term here is the slant asymptote. For the second part of the problem, we have a different function here, and now because I have x squared plus 2, I actually have to go through the long division process of finding the asymptote. So let's go ahead and do that. So I'm dividing 2x cubed plus x squared, and just to get things properly aligned, I'll add plus 0x to the first plus 1, and I want to divide that by x squared plus 2. So first I get 2x here plus 4x squared, no, 4x, not 4x squared, there we go. So I subtract this, and these should cancel, that's why I had to put a 2x over there, and I'm left with negative 4x, bring down the x squared, and bring down the 1. So that's what I'm now looking at. And so then I do a plus 1 here, because x squared goes into x squared 1 times. Multiply it, so I have x squared plus 0x plus 2. I subtract, and I'm left with, well, that's 0, negative 4x, and 1 minus 2 is just minus 1. And now, since the degree here is less than the degree of the polynomial that I'm dividing by, I get to stop, and this is just the remainder. So now here on top, what I obtain is the slant asymptote 2x plus 1. Alright. For problem 5, we are asked to compute a few antiderivatives, and we'll get the general one, so that means we need to make sure we add the constant at the end to give us the most general form. So for the first one, this is just x to the 4th plus c. For this one, it's similar. It's going to, so that when I take the derivative, I end up with, you know, the 4 comes down, canceling that 4, so I'm left with just x cubed. For this one, well, we know the derivative of e to the x is e to the x, so the antiderivative should be e to the x plus c. And for this one, if f of x is e, well, e is just a constant, so its antiderivative is e times x plus c. So that's the difference between these two. Now, what if I have x to the half? Remember, I have to add 1 to the exponent, so I have x to the 3 halves, but I need to divide by 3 halves. And since I already have a factor of 3 halves in front, I'm left with just this plus c. Now, this one is one that I recognize because I use a lot. I know that the derivative of the square root of x is 1 over twice the root. So I'm just going to do it very quickly. This should be just square root of x plus c. Here it's a very similar one, right? But here I'll just use I'll just use the exponent rule that we know. So I add 1 to the exponent, it's x to the 1/2. And I divide by 1/2, which is the same as multiplying by 2, plus c. For this one, now we have a sum, so I have to take the antiderivative of each term. So I have x squared is going to become x cubed, but I have to multiply by the 4 that's already in front and divide by 3, which is my new exponent, plus the antiderivative of the constant is constant times x plus c. Similarly here, we'll do it term by term. So I have x to the 2/5, so if I add 1 to the exponent, it's going to be x to the 7/5. Dividing by 7/5 is the same as multiplying by 5 over 7. So when I have that over 7, I cancel this original 7 here, giving me just 5 times that. Plus, okay, here I add 1 to the exponent, so I have x to the 1/5. And I divide by 1/5, which is the same as multiplying by 5, so I get 40 in front, right, because I still have this 8 to worry about, plus c. Now here I have a rational function, and before I take the antiderivative, what I need to do is I need to fix the exponents. So this is x to the minus 1/5, and since this is in a denominator, I have to subtract 4/5. But that's the same as, okay, 1/5 and 4/5, that's x to the minus 1. So its antiderivative is going to be just natural log x plus c. For the last problem, the idea is similar. I have a fraction, so what I do is first I split the fraction. I have 7 x to the 2/5 divided by x to the 1/5 plus 8 x to the minus 4/5 divided by x to the 1/5. And so this is the same as 7 x to the 1/5, because I subtract, I take 2/5 minus 1/5, so that's just 1/5, plus 8, and now this becomes x to the minus 1. So now I take the antiderivative of this using the exponent rule that we know. So this should be 1/5. I add 1 to the exponent, so it's 6/5. And I have to divide by 6 over 5, which is the same as multiplying by 5 over 6. And on top then I have 5 times 7, which is 35 over 6. Plus, this is just 8 natural log x plus c. So that's my antiderivative for the last problem. Okay, problem 6. We're asked to compute a chain of antiderivatives. We start with cosine x, and the antiderivative of that is going to be sine of x plus c. But now we're asked to find the antiderivative of what we just got, right? The antiderivative of sine is negative cosine. Because the derivative of cosine is negative sine, then I have to fix that by a negative. Plus, antiderivative of a constant is c times x, and plus another constant, we'll call that d. And now we have to do that one more time. So this should now give us finally negative, okay, the antiderivative of cosine is sine, plus, okay, x, the antiderivative of that is x squared divided by 2, so I have cx squared over 2, plus dx, plus some other constant, let's call that e. So in other words, if I start with the function, I'm able to just keep taking antiderivatives, just like so. Now, it's possible to find the values of these constants if I have some, and that's exactly
what problem 7 is asking us to do. So, for problem 7, we want to find the antiderivative that satisfies this condition. So first we'll find the general antiderivative, which is, in this case, x to the 5th minus, this is x to the 6th over 6, but I have a 2 on top, so it's 1/3 x to the 6th plus c, and I know that I'm told that f of 0 is 4, so that means 0 to the 5th plus blah 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 0 to the 6th plus c is 4, but that means that c is equal to 4 basically. Okay, so that means that my antiderivative, not the general one, but the specific antiderivative that satisfies this condition is going to be x to the 5th minus 1/3 x to the 6th plus 4. So that when I plug in 0, all of the x terms disappear, I'm left with just 4 as my initial condition requires. For part B, we are asked to do a similar thing. So first let's find the general antiderivative. That's x squared over 2 minus 2 cosine x plus c, and I'm told that when I plug in 0, I should get -6, so I should have -6 equals, okay, plug in 0, that term drops, plug in 0 for that is -2, because cosine is 0 is 1, plus c. So automatically that tells me that c is equal to -4, which means that the specific antiderivative that we're looking for is just x squared over 2 minus 2 cosine x minus 4. And we can double check, plug in 0 for x, this drops, this is -2 minus 4 gives me -6 as required. Now in the last problem we're asked to do the same thing, except we have to do it twice. So I start with f double prime, and I'm trying to find this a formula for x. Well, first I need to find a formula for f prime so that I can take the antiderivative of that and get f. So f prime in its most general form should be, okay, x to the 7th, 56 divided by 7, that's just 8. Antiderivative of cosine is sine plus a constant. And I know that if I plug in 0, I should get 5. Plug in 0 for x, that's 0, that's 0. Automatically tells me that c is equal to 5, so f prime of x is just 8x to the 7th plus sine of x plus 5. And for the last part, right now I have to take the antiderivative of this to get f. So in its most general form, f of x is going to be x to the 8th minus cosine of x plus 5x plus a constant d, and I know that when I plug in 0, I should get 0. So let's see. These two x terms disappear, cosine of 0 is 1, so I'm left with the equation -1 plus d is 0, which means d has to be equal to 1. So that means that the specific function f is going to have the explicit formula x to the 8th minus cosine x plus 5x, right, everything that we have up to here, and now we replace d with 1. So that's our final answer. And that's the worksheet. That's worksheet 11.